Hey guys, we're going to start the last chapter of the year on trigonometric equations and identities. So we're going to learn about trig identities first. So we're going to do a review of the ones you already learned, and we're going to learn some new ones with Pythagorean theorem. So our essential question is, what's the domain of validity? We're going to verify trigonometric identities algebraically, and then find the domain of validity for trigonometric functions. So vocabulary, a trigonometric identity in one variable is a trigonometric equation that is true for all values of the variable, for which all expressions in the equation are defined. So trigonometric identities are just what we've already learned, like tangent theta equals sine theta over cosine theta. So here are the ones we've already learned: cosecant, sine, tangent, secant, cosine, tangent, cotangent. So all those identities. They're all the same things we've already learned. So nothing new. Make sure you have memorized them. There may be a quiz coming up. So to find the domain of validity, what we're actually asking is, what is the domain? So that's all it means for trigonometric functions. So here I have graphed cosine theta, which is 1 over secant theta. So I've graphed cosine theta here on this graph, and then also secant theta. So for cosine, our domain is all real numbers. There's no restrictions on our x values. But for secant, we have asymptotes. And asymptotes are the places where the inverse of cosine, that's secant, is the asymptotes are where it's undefined. There we go, that's the word. So you can see at negative pi over 2, pi over 2, 3 pi over 2. So at odd intervals of pi over 2, that's where our domain is undefined, otherwise it's all real numbers. So all values except for odd multiples of pi over 2. So I want you to consider this one. What's the domain of validity for secant theta, which is 1 over cosine theta? So you're going to have to graph cosine theta, then graph secant theta. So to verify the identity, we're going to do some algebra. So for verifying this identity, we need to rewrite this equation. So we have sine theta and we have secant theta. Well, secant theta is 1 over cosine theta. So secant theta is 1 over cosine theta. So if we go ahead and multiply both sides of the equation by 1 over cosine theta, that means these are going to cancel. 1 over cosine theta. So we have sine theta equals sine theta over cosine theta. Oops, this was supposed to say sine here. That's why. Secant. Okay, so this is tangent theta. So sine theta times secant theta is tangent theta. All right, and then our domain for sine is all real numbers. And then for secant and tangent, they're excluded at the zeros or the cosine or odd multiples of pi over 2. What about 1 over cotangent theta equals tangent theta? Well, if we know 1 over cotangent theta, well, cotangent theta is 1 over tangent theta. So 1 over tangent theta means that we have tangent theta equaling tangent theta. So it just means the same thing. Okay, so I want you to go ahead and verify that cosecant theta over secant theta is tangent theta, or cotangent theta. And then I want you to compare that with your partner. And we also have Pythagorean identities. So if we use a unit circle, the standard form of the unit circle is x squared plus y squared equals 1. If we take our knowledge of every value on that circle is an xy coordinate or cosine theta, sine theta, if we were to find any point on the circle, it'd be cosine theta squared plus sine theta squared equals 1. Or if just to write it without parentheses, you can write it as cosine squared theta plus sine squared theta equals 1. So we're going to use that to verify a Pythagorean identity. So let's verify that 1 plus tangent squared theta equals secant squared theta. Okay, so I'm going to go ahead and rewrite secant squared as... All right, our tangent identity states that secant squared theta is 1 plus sine over cosine theta squared. And we know that 1 over, or sine squared over cosine squared, we could rewrite that as, or 1 we could write as cosine squared theta over cosine squared theta, so that we can add these together. Sine squared theta over cosine squared theta. So if we can add these together, cosine squared theta plus sine squared theta over our common denominator, cosine squared theta. And cosine squared plus sine squared is 1. So 1 over cosine squared theta. That equals secant squared theta. Ta-da! Okay, so that's just proving that they're true. These are the Pythagorean identities. You will have to memorize these as well. So make sure you commit those to memory. Okay, to verify an identity, let's verify the identity of tangent squared theta minus sine squared theta equals tangent squared theta times sine squared theta. That sounds fun. Okay, so what's another way that we could write tangent squared theta? I'm just going to move this over here. Squared theta equals, tangent is sine squared theta over cosine squared theta. Sine over cosine. And then minus sine squared theta. If we were, that's assuming that this is true. So we need to rewrite sine squared theta with a denominator of cosine squared theta. So that's sine squared theta over cosine squared theta. We would need to multiply both the numerator and the denominator by cosine squared theta. Cosine squared theta sine squared theta over cosine squared theta. Okay, now we can put these together. So we have sine squared theta minus cosine squared theta sine squared theta over cosine squared theta. And sine squared theta cosine squared theta from your Pythagorean is sine squared theta minus, or times, 1 minus cosine squared theta over cosine squared theta. Whew, these are fun. And 1 minus cosine squared theta is the same as sine squared theta over cosine squared theta. So then if we broke that down again, since we have 2, we can make this 1. So we have sine squared theta over cosine squared theta times sine squared theta. This becomes tangent, so tangent theta times sine squared theta, or tangent squared theta. Oh look, they're the same. Wasn't that fabulous? And then last one is simplifying an expression. So we have cosecant theta, tangent theta. We want to rewrite this as one trigonometric function. So we can rewrite cosecant as 1 over sine theta times tangent theta. Well, we know that tangent theta is sine over cosine. So I'm going to rewrite this as sine theta over cosine theta. Now if we were to multiply these together, the sine thetas are going to cancel, so I'm going to get 1 over cosine theta. And we know that 1 over cosine theta is secant theta. So that's rewriting it as one trigonometric function. Alright, here's your lesson check. I want you to do these two as well as the other one that I gave you to do with your partner. And then your homework is to do lesson 14-1. Have a great night.